are interested in energy efficiency in developing countries or energy efficiency in general, because this is really a big topic, and I cannot, probably it's said once and again, but I cannot stop saying that energy efficiency is really the number one option to limit greenhouse gas emissions and enhance the security of our energy supply. And that is confirmed by many, many studies. It was, for instance, the IPCC, the International Energy Agency, McKinsey, Greenpeace, from very different angles, it is said energy efficiency is important. Last year we also published a report. It's called the Energy Report. We did that together with WWF. And you see this picture. And what you see on this picture is that without additional effort on energy efficiency, we'll see a strongly rising energy use in the world, say to probably more than doubling compared to the current level in 2050. But if we are really ambitious in energy efficiency effort, we can reduce that very much, and we can end up at a level that is very close to the current level of energy consumption. So globally, we can stabilize energy consumption. And that's an important finding. That means that in the industrialized countries you will have even a reduction in energy consumption. In developing countries you will have a growth, but on the balance you will have globally an energy consumption that is comparable to the current level. But energy efficiency, although it is very attractive and everyone says it is attractive and it is number one option, it does not come automatically. Say a lot needs to be done to get it happening. And in all the sessions that we had, a lot was already talked about what governments, what programs can do. Today I'll focus on the specific situation of companies around the world with an emphasis on developing countries, and I will discuss a number of topics. First I will move into how do we define energy efficiency. I will move to the topic of benchmarking, and at the same time also present to you how energy efficiency is, or what the status of energy efficiency is in different parts of the world. I will give an overview of energy use in industry and buildings, and then come to the main topics, energy audits and energy management. So how do we measure energy efficiency? That's basically a very simple way, say different from how you measure energy efficiency of a power plant or the energy efficiency of a boiler, where you measure energy efficiency by dividing output by input, but here you do it the other way around. You divide, when it comes to end uses, for instance in industry and buildings, we divide input by output. So energy, we normally measure energy efficiency actually as the inverse of energy efficiency, and we call that specific energy consumption, and that's the energy use per unit of activity. And that can, for instance, be expressed in megajoules per ton of steel, megajoules per square meter of office area, or megajoule per vehicle kilometer. Sometimes it's more complicated. Say for instance, if you have a fridge, you can measure the energy consumption of the fridge by measuring kilowatt hours that it uses per liter per year. But if you have a fridge-freezer combination, it's more complicated, because it is it wouldn't make sense to measure the energy consumption as kilowatt hours per liter, because that would very much depend on the how much fridge compartment there is and how much freezer compartment there is. So in this case we apply a weighting, and we say, okay, the volume is the refrigerator compartment plus 2.1 times the freezer compartment. That's the formula that was used in the European Union. But you can imagine that you can do that in many cases. We see, for instance, a company could make different types of steel. It could make cold rolled steel and hot rolled steel. And for cold rolled steel, you need more energy than for hot rolled steel. So then we use such a weighting system. And we call that the energy efficiency index. So the energy efficiency index is very much the same as a specific energy consumption, but we use it in the case where there is a mix of different products or a mix of different activities. And we do not care whether that's a mix of fridge and freezer compartment or hot rolled and cold rolled steel. What is then energy efficiency improvement? That's then simply following up on the previous formula. That's reducing the energy use per unit of activity. And it is one thing that I always want to stress is that energy efficiency is not something new, something that was invented since 30 or 40 years, the first oil crisis or so, but it has been with us for a long time already. This is, for instance, the specific energy consumption for making iron in blast furnaces. And you see 200 years ago we used 300 megajoule per kilogram of steel, and now that has dropped to about 12 megajoule per kilogram of iron. So you see a dramatic improvement of the energy efficiency measured as a reduction of the specific energy consumption. But okay, the question that we have on the table is, we see this automatic improvement, autonomous improvement as we often call it, of typically 1% per year, but can we speed it up? Can we go to 2 or 3 or maybe even 4% per year? So far as the definitions of energy use and energy efficiency are concerned. I will now move to the next topic, and that is, where is energy used for? I said we will use at these two sectors, industry and buildings, and more specifically service sector buildings. What do they use their energy for? And you see that a breakdown of the energy consumption to sectors in this picture. You see here that industry is very important. This is a global picture, so this picture is valid for the entire world. It was published it was a picture from the Global Status Report on Energy Efficiency that we published in 2008. You see industry is very important, roughly responsible for 1/3 of demand on primary energy use. You see that buildings together are also responsible for 1/3 of global energy use, and the service sector is a small part of that. It's roughly 1/3 of the total buildings energy use. Actually, also this says here buildings, but what's meant here is homes, residential sector buildings. So, but we look at these sectors, services and industry. Let's go a little bit further then to the industrial sector. In this picture you see the breakdown of energy use in the industrial sector in two types of, for both OECD countries and non-OECD countries. And you see that for the industry for OECD countries, for non-OECD countries is already quite a bit bigger than for OECD countries. For OECD countries, we see that chemicals and petrochemicals are very important. Also iron and steel is an important sector, but not say it doesn't have the share of the energy consumption anymore that it used to have. Pulp and paper is a very important sector. Non-metallic minerals is important. Aluminium is the biggest there, and food and beverages. And for the rest, the energy consumption is spread across a large number of a variety of sectors. And that's always the difficulty when we talk about industry, that energy consumption is so diverse. Every sector has its very specific production processes, and it's very difficult to find a common denominator. So when we move to non-OECD countries, we also see that chemicals are important there. And within chemicals, it's always a few sectors. Say the chemical sector is very diverse, from ranging from naphtha crackers that produce petrochemicals to pharmaceutical production. But in general, the main energy consuming activities are production of petrochemicals, ammonia production, chlorine production. Methanol is sometimes important. So these are the big processes in the chemical industry. But next to that, you have a lot of smaller processes. Iron and steel production is very important in developing countries. What's also important, much more than in OECD countries, is non-metallic minerals, as it's called here. And the big one there is cement, but also building bricks, glass, etc. belong to that sector. Also here you see a variety of smaller sectors, and you also see a large category non-specified, which means that the statisticians have not identified what specific sectors these are in many cases. And you see for non-OECD countries that is quite substantial. So this is about the sectors where energy is used. That is relevant, but we can also look, okay, for what type of application is the energy used. And we get a glance of that in this picture. So in this picture we see the breakdown of industrial energy use. This is for the US. But when you see pictures for other countries, it's often very much the same. Of course, the exact ratios are different, but you see always a similar breakdown. What you always see is that for when you look at to electricity, and that's the left chart in this picture, you see that motor systems, so driving equipment through electric motors, takes up the largest part of the electricity use. In this case it's 52%, but there are also countries where there's even 75%. And that is an important one. You see that electricity are also used for process heating, sometimes because electricity is cheap, but also sometimes because electricity can be a very convenient heater. You see electrochemical processes are important. That's, for instance, chlorine production, cooling, lighting. They take up smaller shares just as facilities. Having said that, it seems like there is quite some uniformity, because part of the energy is used for motor systems, but these motors are driving a large variety of different tools. So the uniformity, at first there seems to be uniformity if you see where electricity goes to, but if it's then converted to power, it can drive all kinds of different equipment. The same is valid for when we look to the fuel use. You see that much of the fuel is used basically for heating, and that can be direct heating. That can be via the production of steam in boilers, which also is used for heating, but often at lower temperatures, say 100 or 200 degrees. And it can be used for cogeneration, combined generation of heat and power. But also in that case, the steam or the heat that is produced is used in many different processes. So also here we see it seems to be a limited number of uses, but in practice the heat that is created is used in a variety of processes. The situation is quite different in the buildings sector. Here we see a typical breakdown of electricity use for buildings, and electricity use for buildings, for a typical office building, electricity use is responsible for a large part of the primary energy consumption, 50% and often more, which is different from industry, where it's a small, where fuels are responsible for a larger part of primary energy consumption. And here you see that in buildings, the services, in office buildings, the services that are supplied by energy are much more uniform. Lighting is still very important. It used to be 50% or more in the past, but now it's still typically 1/3. Can also differ from country to country, of course, but it's still very important. The newcomer is ICT, and that can be central ICT systems and decentralized ICT systems. Nowadays also very important. Air conditioning and so cooling and ventilation are important categories, and then you have a number of other categories. For instance, in some cases the restaurant facilities are important, internal transport. Pumps are of course used for heating, ventilation, air conditioning. So it's the a mix of activities, but it is a number of fairly well-defined services. That's the case for electricity. For fuel, it's also quite uniform in most of the cases. Space heating, if it's applied, of course, there are many developing countries where space heating plays only a minor role, but if fuel is applied, it's most of the time mainly used for space heating, and of course there are other applications, sometimes cooking, but that is very, very minor. So we see quite a difference in type of energy use in industrial sectors and service sector buildings. Say industrial sector very diverse, a large focus on processes. In the service sector, much more uniform, limited number of applications, and quite well defined. What is different in the service sector is that the interest in energy is much lower. Say many industries are quite energy intensive, and that leads to quite some interest in using energy in an efficient way. Although I must say that's also only valid in the heavier industry types like cement and petrochemicals and steel, and not so much in, for instance, machinery. But anyway, there is quite some interest. That is often not the case in office buildings. And an illustration of that is that in office building, often a large part of the electricity, but also fuel consumption is used outside office hours. And in this picture, it seems that it's lighting, and of course you often see such things that in the evening when no one is in, the building is completely lighted. But okay, we have seen programs and many people switch off the lights when they go home. But you see, in addition, you see there is a lot of hidden electricity consumption in buildings. Say there are pumps and fans that run day and night, and also in the weekends. There is ICT equipment and copying machines that stay switched on, etc. And that is typically that hidden electricity consumption that no one sees, but that nevertheless can be responsible sometimes for more than half of the electricity consumption in the building. So you could say, even if an office is in standby, then it still uses energy, much the same like our equipment at home. So far, about to provide a brief overview of, okay, what is energy? What is it used for? Because we have to have an idea what energy is used for before we can start managing it. The first tool that I want to discuss with you is benchmarking. And benchmarking basically is a very simple tool. What you do, you apply the formula that I showed you before of the specific energy consumption. You apply that to a number of companies and you compare them. And this is, for instance, such a benchmarking exercise for cement plants in Shandong Province in China. So 16 cement plants for each. The specific energy consumption was measured, in this case described by the energy efficiency index, and that has to do with the fact that sometimes cement is made from primary raw materials and sometimes made from secondary materials, and they have different energy consumption, so that's why you apply an energy efficiency index in the same way as you do it for the fridge-freezer combinations. So there's an energy efficiency index, and the best plants operating in the world have an energy efficiency index of 100, or it's scaled to 100, and you see how these 16 Chinese plants operate. And you see the best is about 20% higher, and the worst has a 60% higher energy consumption than the world's best plant. And this is very useful. So in this case, if you would be plant number 12 in this list, you see, okay, there is quite some room for improvement. Most of my colleagues nearby do quite a bit better than I do. So not only for, be it only for my competitiveness position, I must have a serious look at my energy consumption, because my colleagues have probably 20% less, my best colleagues have 20% less energy cost than I have. So that is an important reason why benchmarking is a good tool, and that's also why it's applied in many government programs. What I'll do next is to show you some examples of benchmarking across the world, and to give you an impression, okay, what's the variation, and this is for copper. And you see here a typical benchmark curve. Here you see so many plants. So this is not individual plants, but it's cumulative production. So there are small plants and big plants. So that's why it's not. It's a line that is not very fluent. But you see on the left you have the most efficient plant that uses less than 8 gigajoule per ton of copper, and the least efficient are use more than 20 gigajoule per ton of copper, and there are even some extremes that use even more. And that's something that I do not know what the explanation is in this particular case, but you always have companies that have an exceptional processes that make it more energy intensive. I do not know what the explanation is in this case, but I remember that for instance one company that was producing paper, but they were producing paper to make banknotes, and that required quite a different production process than common paper, and they had they are extremely high energy consumption. So you always have exemptions. In this case, in the case of copper, you didn't see the distribution in the world, but here you have a benchmark curve for aluminum, and the red curve is the curve for all the individual plants, and the black curve is a similar curve, but then grouped by regions. So all the plants in Africa were taken together, and the average is depicted here. So in this case, Africa is the most efficient continent, and then we get Asia, and the very last one is Europe. And I started with this picture to start with the message. It is not always what you think. Many people think, okay, the developing countries are always very inefficient, and we need all kinds of technology transfer programs and CDM and what have you, NAMAs, to bring efficient technology to these to countries in the to developing countries, to non-OECD countries. And this already illustrates that this is not always true, and we see that in many other cases as well. In this case, it's exactly Africa that's doing best and Europe that is doing worst. I must make two notes here. Say the difference is very small. Say this picture doesn't begin, say that the vertical axis doesn't begin at 0. So the differences are just a few percent. And the other point is, okay, we have international, these benchmarking exercises, they rely on a lot of data to be supplied by companies in many cases, and the reliability cannot always be guaranteed. We go to the next picture. This is about steel. Here we again have an energy efficiency index for the reason that I already explained. Companies make very different types of steel, and that's why you cannot say simply the energy consumption per ton of steel, but you need to correct for the type of steel that is produced. Here you only see the breakdown by region. And this is a much more familiar picture. You see in many cases Asian countries, and especially Japan and Korea, are very efficient. Europe is relatively efficient. China used to be quite inefficient, but it has catched up very rapidly. And in this case you see that the economies in transition, say the Russia and other countries in Eastern Europe and Asia, they are the least efficient. The reason that countries, say, in the case of Japan and Korea, the reasons that they are sometimes very efficient is they have a relatively young industry. Energy prices in especially Japan are very high, so that's a reason to pay a lot of attention to efficient design of manufacturing processes. This is the case. This has a lot of lines, but let's only look at the black line. Here you see this is for ethylene production. Say this is petrochemicals, naphtha cracking. Also here you see that countries in Asia are doing very well. Europe is second. And okay, then you get other the other regions. This is ammonia. Again, in this case, Europe has the most efficient ammonia production. But you see all other regions. South Africa is doing quite well. Middle East, India. In this case, China is relatively inefficient, and that for ammonia, this has to do with the fact that in China there is a lot of coal-based ammonia production, and that is inherently less efficient than natural gas-based, what's the case in many other countries. So you see a very mixed picture. Say you cannot say that certain regions are better than others. Here we see the picture for clinker, which is an input for cement production. In this case, India is doing quite well. And finally, I have a picture for paper production. And okay, again, I can repeat, but you can look for yourself. So in general, first of all, I must say that these pictures were compiled for UNIDO by colleagues of me at Utrecht University. And they took all the information that is available at present, with a disclaimer that I already presented before. In general, what you can say if you look at the entire world, and first of all, the message should be, okay, there are no particular efficient or inefficient countries. Roughly speaking, you could say that Japan, Korea, and European countries often are among the most efficient in the world, but not always. And then you have, for the rest, it depends very much to at which sector you look. The US often is not so very efficient. China used to be very inefficient, but is catching up rapidly, and Russia stays a relatively inefficient country. I would have been happy to show you more information about similar information about the service sector. That is actually not available. You see here the energy demand in the service sector per capita, and you see wide differences between the G8 countries and major developing countries. But the reason for that is mainly that that the service sector in these G8 countries is much bigger than in the others. But you see also a rapidly developing service sector, for instance, if you look at the picture for China. We have information on the specific energy consumption for space heating. This is the picture for a development of space heating energy requirement per square meter and corrected for degree days. And you see there is quite some difference. In this case, United States and Canada are doing fairly well. Europe is not so good in general. Japan has a very low energy consumption, but that has to do with the fact that often a smaller part of the energy of the home is heated. So there is this quite a complicated story, these international comparisons. Okay, so far this hopefully gives you a picture where we stand internationally. Let us now move to energy audits. And energy audits are very often mentioned and often considered as a very good solution for to make companies work towards energy efficiency. And that is to some extent true, but there are two requirements. First, you need to do good energy audits, and second, you need to standalone energy audits often do not make much sense. So you need to embed it in a larger process. So what do you do in energy audits? Here the three main elements are mentioned. Say you need to understand. You go to a company or to a building, and you need to understand how energy is used in that building. The second is you identify opportunities for energy savings, and energy savings is for me a synonym in this case to energy efficiency improvement. And finally, you do a cost-benefit analysis, and on that basis you can make recommendations for a company or organization what to do. Let us have a further look at these three elements. First of all, you need to understand how energy is used, and often you often apply a certain procedure for that. You first start with looking at the total energy use, and the simplest way is to look at the energy bills, because that may often not for 1 year, but for a number of years, you see, okay, how much energy is used. Is there a change? Is there a variation? What is more important, electricity or natural gas or coal or other energy carriers? Second, you go into the company and you make a registration of all the equipment that is there, all the energy using equipment. That can be boilers, that can be all kinds of motors and other equipment. You can see, okay, what's the capacity, the the power that the equipment use, you can make estimates, of course, often on the basis of what the people in the company tell you of the operation time. Is it used only permanently or only at daytime or irregular? What is also very important is that you determine the thermal characteristics of the buildings, because especially when you talk about space heating, which is an important energy use factor, or cooling in buildings, that's to a large extent determined by the fact by how well the building is insulated, what the K values are. What is often needed is measurements, because additional measurements, and that can sometimes be that you measure the patterns, or that you just measure for 1 or 2 days to get an idea how often certain equipment is running, but sometimes you need more time. And you need that to draw up a complete energy balance. And that is, I also mentioned that as a number one deficiency in energy audits, that the energy balance is not closed. I've seen many energy audits in which the total energy use is given, then an inventory of all the equipment is made, and an estimate is made of how much they consume, and that in the end it is not possible to explain more than half or 2/3 of the total energy use. And if you and that could well be that other half or other 1/3 of the energy is wasted, but you do not know. You do not know where it is wasted. So if you don't have the energy balance closed to a large extent, that you can completely explain what the energy is used for, then you start with a very you make a very bad start for your energy audit. Once you have drawn up the energy balance, you determine load profiles, say not only how much is used in a year, but also how that is used over the day, or over the days, the individual days, weekend profiles, over the different months, because that is important for the further analysis. And what also could be an element then is that you apply benchmarking. If these data are available, it's good to compare your specific situation, your company or your office building, to others, to see, okay, where do we stand, because that gives you a first indication, okay, do I have a big savings potential, or would I expect only a limited potential? Okay, the second part is to identify opportunities for saving energy. And there is a large variety. Basically, you can already tell from my introduction, where I said, okay, there are so many different industrial sectors with all different processes, that especially if you work in industry, no two energy audits will be the same. But you can make a certain categorization. First of all, you have generic building-related measures. Say, as I already said, in office buildings, energy consumption is relatively uniform. Although I've never seen two office buildings that are completely identical, but you have the same set that you always can apply. You talk about insulation, different types, walls, floors, roofs, glazing. You need to control ventilation, see whether there is a lot of air leakage. You need to look at lighting, more efficient lights, high frequency control of lights, switching light on the basis of presence or daylight. You can apply condensing boilers or heat pumps. the second category, when you go to industry, you have a number of generic industrial measures on motor systems. I will come back to that, and heat recovery. Compressed air systems and steam systems can also be looked at. Of course, also here you can apply insulation, but then insulation, for instance, of steam pipes. But then you get to a completely different category for which you need to have very specific knowledge when it comes to process-specific measures. If you go into a certain industrial company and you see process-specific, you see that industrial processes take up 2/3 of the energy consumption, which is very common, then you really need to dive into these processes to see how energy can be saved there. And finally, you should also look to the heat supply and see whether combined generation of heat and power is attractive. But I think this particular thing, these process-specific measures, I think that's number 2 deficiency. If you say number 1 is that the energy balance is not close. Number 2 is that only attention is paid to generic measures or maybe generic industrial measures, but that real process-specific measures are not taken into account, and that also overlooks a substantial part of the potential. Okay, the final step then, once you have made the inventory, you do the cost-benefit analysis, determine the payback time of the measures or other indicators like net present value, internal rate of return, whatever is more common in the industry that you look at. An additional possibility is to look at cost-supply curves. I will briefly introduce them, but first have a look at a number of, give some examples of how these generic industrial measures can be analyzed. For instance, this is about motor systems, and the top picture indicates a traditional motor system. And this is a standard motor. It's running, in this case, driving a pump. And the output flow of the pump needs to be regulated, and that is done by a throttle in this case. And of course, a throttle is just creating more friction, which is creating energy loss. If you want to move to a more efficient system, you leave away the throttle, and you replace that in the bottom picture by a variable speed drive. And a variable speed drive is in fact a frequency converter, so it can change the frequency of at which the motor runs, and by adapting the frequency, you can control the turning speed of the pump, and by doing that, you can control the output of the pump. The second thing is that you do is to apply a high efficiency motor, which delivers a substantial improvement, and then you have a number of other measures. You can improve the coupling, you can have a more efficient pump, and you can have more low friction pipe. And of course, you can also look at the further system, because this pump is delivering some liquid flow to something else, and also there may be possibilities. But in this case, say the variable speed drive is number 1 and the high efficiency motor is number 2. But this whole package is considered as more efficient motor system. That is in most studies that I've seen, you see conservation potentials of more than 30% in motor systems. Another important option is heat recovery, and in more general optimization of heat exchange systems. That is, I will not go into detail, but you can apply a certain approach that's called pinch technology, and to the right you see some pictures that illustrate it, but it would go too far to really dive into the details. But what you do is you make an inventory of all the heat flows in the process, so the heat flows that go into the processes and the heat flows that leave the processes. And with help of the pinch technology, you can design an optimized heat exchanger network. And in many cases, huge savings are possible, say 50%, sometimes even 80%. But at a cost, say, or sometimes the investments can also be substantial. This is an example of steel industry, very specific processes. There's nothing like that in other sectors, and you can also, I would say, only if you are a specialist in iron and steel making, you can do a good energy audit of a steel mill. Combined generation of heat and power, I will skip that. This is gas turbine cogeneration. If that is available, that's by far the best solution. But many countries only have coal, and then you can have a steam turbine-based system. This is an example of an inventory of all the energy saving possibilities for the same 16 plants that I mentioned in China. You see, in this case, a conservation potential for electricity of 40%, of which 16% is cost effective even at the discount rate of 30%. Fuel conservation potential is 80% in this case, so somewhat more limited, but that's often the case that you often see that for cement. What is very useful, and this is a cost supply curve, you probably are familiar with the cost supply curves that are nowadays often indicated as the McKinsey curves. But that were already, say, I made my first cost supply curve, I think, in 1990, so they are much older. But what you do, you can do that with measuring the cost per ton of avoided CO2. But here in this case, you measure the cost of conserved electricity. So what is the cost per unit per megawatt hour of energy saved, and you then you do that for each individual measure. So in this case you have 23 different measures. For each measure you determine, okay, what are the costs, the investment costs and the operation and maintenance costs over the lifetime per year, and then you rank them with starting with lowest cost to medium cost and high costs. And then this gives you you compare that with the electricity price, and that's in this case indicated by the dotted line. You see here then, okay, this is where the cost-effective part is, and this is a 16% that I mentioned before, and this is 40% for electricity, which is a technical potential. Of course, if you would apply a different discount rate, this part would drop substantially and the potential would become much higher. But of course, that always depends on the possibilities of the industry to invest in new technology. So the final point. There's something similar for fuel. The final point that I want to make, okay, energy audits are good, but let me stress, energy audits
Joining the meeting.
Okay, it seems to be...
Invalid entry.
Yeah, can I continue?
Yes, you can
Okay.
go ahead again.
Yeah,
Sorry.
yeah. Okay, no problem. Sorry that I take a little bit too much time, but okay, I'll be finished in 5 minutes. So energy management is key, and energy management is a continuous process. That is important. So there are some principles for energy management that are important. It must be a priority. And not a priority from some individuals in the company, but from the management. There needs to be a broad commitment to energy savings, not only for the energy management, the people responsible for energy management, but at all levels, from the management to the work floor. But of course there must be clear responsibilities assigned, who is responsible for that. It doesn't work if you do not want to invest. Say you can have first savings that are virtually free, say good housekeeping type of things, but at a given moment you really need to invest. And as I already said, it needs to be a continuous process. That's all, and that is depicted in the following slide. Say it starts with making commitment. You need to assess where do we stand, and basically here the energy audit comes in, and then you should set goals. Okay, you make a plan of several years to reduce the energy consumption or improve the energy efficiency. You create an action plan, you implement it, and of course after some time you evaluate it, you recognize achievements, and you start the cycle again. And now and then also you need to do a reassessment of the whole thing. And then what are the elements of energy management? Then energy audits come in. If you have embedded in such a structure, then energy audits can be very effective because then you really need them. You really need good energy audits to make good plans, to make the right investments. You need to make teams of people responsible. It doesn't work without employee awareness. And last but not least, you need to have good monitoring in place. Say when you start an energy management program, you often have limited data. Many buildings, for instance, nowadays have a building energy management system, but they're only used to control the buildings, just to make the settings. What temperatures do I want to have? What flows? But you can expand building management system to energy with energy monitoring system, so that you get also information. Okay, how does my building perform? And the same for industrial processes. Last but not least, I would say you not only should you should give people assignments. What should they do? But also you should give them incentives. And what works very well if many companies have a system where the salary depends on performance, and you can put energy elements in that. And we had a nice example of a client of us, the Belgian Post Company. They introduced for the managers of their mail distribution systems, they introduced a bonus based on the energy consumption of that was related to the energy consumption of the buildings, and they introduced that in 2009 for the first time, and immediately they saved 10% from one year to the other. So that, I would say, that's also an important cornerstone of any energy management. Finally, I can say, of course, this is just an introduction. I want to point you to two interesting reports that colleagues at Ecofys and Lawrence say the first report was produced by colleagues at Lawrence Berkeley, the second by colleagues at Ecofys, Evans Sorel and Tana Angelini, but also under the umbrella of Lawrence Berkeley National Lab. They have prepared some very nice guidebooks, one on energy audits and one on energy management. And the energy audit guidebook is also especially focused on application in developing countries. So this is good stuff for further reading, I would say. Okay, thank you very much for your patience and your attention.
Okay, great. Cornelis, thank you very much for this interesting presentation. So from now we invite our audience to submit your questions. So in the meanwhile, maybe you can give us, Cornelis, a few more ideas on well, all these tools that you have presented on practical basis. Do you find any concrete application in any particular country? Do you have any experience on having applied concretely any of these tools for any advice to governments or in the definition of energy efficiency policies for any country?
Oh yeah, yeah. Let me first say that the difference. I would say we increasingly live in one world, and that's also the case when you get to these topics. When I said that I often encounter very worse energy audits, very bad energy audits, this is just as well the case for developed countries as for developing countries. So there is not a real, in many cases there is not a real difference. Also when you look at industrial processes, the processes are very much the same. Say that may not have been the case 50 years ago, but for instance China had completely different industrial processes than the rest of the world, but that's much less the case nowadays. So many of the things are valid, many of the things that I presented are valid everywhere. I've done most of the work that I did is in China, and there we were what happened there, and that links to the rest of the program. Say there we have done quite some work on how to implement experience from the Netherlands, the UK, from Norway on implementing energy efficiency programs for companies, how that works. And we looked at all kinds of different approaches, and of course that is energy audit, but also more sophisticated analytical tools. We applied benchmarking. We examined, okay, how can targets be set for different companies. We looked at all that material, and that is we did some pilots in provinces in certain provinces in China. We did that together with the people at Lawrence Berkeley National Lab, and finally we the Chinese administration has taken that up, and that was later translated in what is now the Top 1000 program. So now the Top 1000 program now rolled out nationally. That is the the 1,000 biggest industrial companies are responsible for about 1/3 of the energy use in China. They all have now targets and are implementing all these tools to bring their energy consumption down.
Very well. Thank you. So we have the first question from Jean-Sebastian. You presented comparison of energy efficiency indicators between countries. What about the link between energy efficiency or energy savings and business cycles? Let me finish the question. In particular, would you have references about the impact of economic crisis or growth on energy efficiency in the industry?
Yeah. Okay. Yes, good questions. Now, as I already started saying, everyone is saying that energy efficiency is a top option and it has huge potential, but in practice, the progress is not so much as could be. In some cases, it's really disappointing. And that also refers a little bit to your first question. Say, it's never, I would say, it's always a good time to invest in energy efficiency, but for many companies there's never a good time to invest in energy efficiency, because if you are in a if the business cycle is in an upswing, then you want to invest in expansion of your production and to follow the market, and do not have time to pay attention to such thing as energy efficiency. And if the business cycle is going down, you are going to cost cutting, and you do not have the money, you do not want to make the money available for energy efficiency improvement. So it seems like it's never a good time for investing in energy efficiency. So that's a little bit a problem. So that's also why these things need to embed it in one or the other way in government programs. And I already mentioned the Top 1000 program in China. In other cases, you have voluntary agreements. In other, we also I recently chaired a committee that had to make new proposals for energy efficiency improvement, and one of the proposals was that, okay, as soon as companies get subsidy to invest in energy efficiency, and many countries have subsidy schemes or fiscal incentives, that as soon as a company gets such an incentive, that they are forced to implement an energy management system, because doing just single investments in energy efficiency has limited use if it's not embedded in a more comprehensive energy management system. So you need say some embeddedness, say in larger programs, is necessary to really make it to really make it going. The second question is, the impact of the economic crisis is difficult. It's difficult to say. It is not easy to measure progress in energy efficiency on a large or on the scale of, for instance, a country or of an industrial sector. So actually we do not know. We see in many cases that the energy consumption is dropping, but that is often related to the reduction of industrial activity and has nothing to do with energy efficiency.
Thank you, Kornelis. Next question from Macheta Pani. What suggestions would you give to energy policy makers and regulators?
Okay, there is there are many suggestions. I would say in general the number one thing is information and communication. I think make information available. For instance, what is often already very attractive is to introduce benchmarking schemes, so that you help the companies to look at each other, but also information exchange. Sometimes, in many cases, it's very helpful for companies if they see how others are doing. So that is an important first step. But the next step is that you also define concrete targets. That, okay, once you have this benchmarking in place and you know how your industry or your service sector compares to the rest of the world, or how certain companies compare to others in your stock of companies, then you can set concrete targets, and that can be targets on absolute energy use, but also targets on percentage energy saved or energy efficiency improvement. And that target setting can be done in different ways. Say it can be done as it is done in China. That's in the end a fairly top-down target setting process, but it can also be through voluntary agreements in different forms.
Okay, good, thank you. Next question by Kurt. Should a company employ an energy manager or energy
Definitely. No, that is key. Say that is all. I already said that in many service sector, in many offices, there's no one responsible for. Say the attention for energy efficiency is very limited, And one of the reasons is that there's no one is taking care. Say, energy is just a bill that comes in every month and that is paid by the financial department. So you need to have an energy manager for, of course, for a small company that cannot be a full-time person, but at least sometimes it has a responsibility, and is also, and what is critical there, of course, that such a person has the backing of the higher management in the organization. So so in a small company, you need to have you can have an energy coordinator. A somewhat larger company, you can have a full-time energy manager, and in a big company, you really need to have a department. If no one is responsible, it will only go the wrong way. But in any case, it's important that these people are empowered, that they get the right instruments to make change happen.
Next question from Kurt again. Can CDM and other voluntary schemes provide sufficient incentives for energy efficiency investment in developing countries?
Yeah, that is not easy. Say we have done say definitely at current CDM prices, but also at higher prices. If you look at a industrial CDM project, then only a small part of the benefits come from the carbon credits. Say if you carry out an energy efficiency project, 80% of the annual benefits is just saved energy costs, and 20% or less is carbon credits. So CDM alone will not make push energy efficiency. Voluntary schemes, that's different. And we have examined many voluntary schemes, and sometimes they work, sometimes they don't work. What we found is that voluntary schemes, or voluntary agreements, or negotiated agreements, or whatever you call them, only work if there is a lot of effort from the government to stimulate it. And that can be done in various ways. For instance, in Denmark, voluntary agreements were very effective, because if you didn't comply with a voluntary agreement, you had to pay an energy tax. So that was the voluntary agreement. The term voluntary was not really the right word there. Basically, companies were forced to enter voluntarily into the agreement. But that is. But there are also voluntary agreements that were very disappointing. So the effort from the government, and that's really critical.
Okay. Next question from Kurt. With the compliance with ISO, actually I think 50, yes. Yeah. 50,001. Yeah. Automatically save any energy?
Yeah. No. Basically, ISO 50000 is about energy management systems, and energy management systems they are critical. So if you really want to work systematically on energy efficiency improvement, that can bring a lot of savings. But you really need to implement, you need energy management system, but you also need to implement it in the right way. And I came up with one of this report called Managing Your Energy. That report also contains a checklist to check energy management systems again. So and of course in ISO 50000 you look at the quality of energy management system, but it is just the first. It depends very much on the targets that you have, the involvement of the management, etc. A system alone will never do. There must also be a driver. There must be ambition, or external pressure or whatever to make it really work.
We also have a comment about this ISO 50000. If you could comment on it. So could you maybe give a very quick view on what is inside?
Yeah. Now the ISO 50000 is a formal system like you have ISO 9000 for quality management. ISO 50000 is for energy management. So it's the well-known how you set up procedures, share responsibilities, etc. And it's very good that it exists, and it's everyone implementing energy management should start with something like that. But there are some other alternatives. Say there are local alternatives. For instance, in the US you have the Energy Star. Under the Energy Star program there is done a lot on energy management. So that is all already invented by others, so use ISO 50000 or something comparable, but in the end you have to do it yourself.
Okay, perfect. So let's go for next question. How much impact can behavior change and reorganization, changing of timing of processes or operation have on energy efficiency?
Yeah, that can be a lot, but that depends very much on where you. It also, first of all, depends on what behavior change, because but by just sometimes by just making simple changes. Having people switch the light off, and that often doesn't work because you cannot push people to do that. So you rapidly move in something that does that automatically. But the potential can be big. But behavior change is always difficult to maintain. So in fact, behavior change as such hardly exists. What you often do is to combine it with something technical, something that supports the behavior change.
Okay.
So for instance, it's much better to have computers automatically switched off if they are not used for some time than ask people all the time to switch off the computer if they leave their office.
A comment rather than a question. You didn't get to talk about ESCOs.
No.
Any resources you can recommend on the topic?
Yeah,
I have to say, excuse me. I have to say that the previous session was fully dedicated to ESCOs model. So you can go to Leonardo Energy website, and then if you go for this course, take lesson 9, and you will find there full information. Otherwise, Kornelis, I'm pretty sure you have a very nice suggestions, so please go ahead as well.
Yeah, no, I do not have say that is what I wanted to say. So start with that. I saw that one, and that's very useful. So I would start with that one, and there is no generic say there are several people at the Joint Research Center in ISPRA of the European Commission that have published on this. Lawrence Berkeley has paid attention to it, but there is no general guidebook on ESCOs, and also ESCO is not one animal, but it's a complete kingdom of all kinds of different animals, so there are different types of ESCOs, and all have their own pros and cons. And it's not hard, it's not easy to get an ESCO working. Let me also stress that.
Okay, good. So I think there is no more questions left. So it's 1 hour 20 since the beginning. I think that was a very nice session. Okay, so there is just expression of interest to be further in touch, and congratulations for the session. So indeed, thank you very much, Kornelis, for this bright speech. And thank you very much to all our audience for being there for the last session of this course. So we will be proposing new courses and new webinars, so just remain in touch with our website, Leonardo Energy. Go as well to Clean Energy Solutions, as we will be co-organizing these events. And Kornelis, I let you close the session.
Okay. So thank you very much for attending. Hope it was useful for you. If you need more information, please get in touch.
Okay, so Kornelis, thank you very much. I stopped now audio broadcast. Let me as well